Assalamu alaikum. This is Adil here. Hello, BCom 4933 students. So this lecture, we already covered it in week 7. However, I thought it would be a good idea just to quickly remind you of main concepts that we covered back then, because I think some of the concepts you might be using them, and you will revisit them when you're doing your final paper. Okay, we talked about egocentric network, and you know what is egocentric network. So let me just explain that again. Okay, so with egocentric network, we say that let me just click. If this is a node, this is a person, a vertex. It can be a person, an individual, an entity, organization, a country, or anything. So if this is you and you are connected with other people there, you are connected with many people, you see, everyone is connected with the other person there. However, this is your own, this is your network. So this is you here, this is you. So maybe probably this is connected with other people. You see, this is connected with other people there. You see what I mean? So basically, what we are saying, egocentric network, if this is you, your egocentric network is this one. You have one connection, one tie or edge, and this one, and this one, and this one. Now, here we call you as a node or as a vertex, and this connection here is actually, we call it an edge or a tie. So this one is an alter to you. So this is an egocentric network. These are your alters. This one here, your alter, your alter, your alter, this one too, and this one too. So that is egocentric network. Now, if we talk about this guy here, this person, let's call him B. You are an A. This person also is the egocentric network of this person would be this one, you know. This is his own network. So this would be very useful for us later on when we do clustering or with the relational data. Okay, now we have also as we said before, that there are mainly several types of network, but mainly we focus in this class directed network and undirected network. So there is also mixed, but let's talk about the where the connection between people, the directionality doesn't matter or irrelevant. For example, you can consider that like the case of married, unmarried, your classmates, that there is no sort of like maybe influence, unless there is influence, I don't know. But this mainly we refer to this as undirected network. With the directed network, directionality matters. So for example, you can have a manager and subordinate. You see, so there is an influence there. Who reports to whom? Who influences whom? So let's take an example of, so this is the formula of counting the total possible ties in undirected network. So let's do some calculation, basic one. Okay, so let's assume that we have 4 nodes. We have 4 nodes here, okay? These are 4 nodes. You can call them A, B, C, D, you know, or node 1, node 2, node 3, and the 4th one. Okay. So, if I ask you how many possible ties are there, you'd be like, okay, that is simple. I'm just going to draw like this, you know, the possible ties. Each one is connected with the other person. And you'll be like, okay, 1, 2, 3, 4, 5, 6, which is correct answer. However, what if I give you like 1,000 nodes? You won't be able to do this, to count each tie or each edge. So you need a formula. And the formula is The formula is n squared minus n divided by 2. For the undirected network, you need to divide by 2. But for the directed network, you don't need to divide by 2. We'll see that later. Okay, so basically n is the number of nodes. So let's take an example. Okay, great. So let's go back again to our own 4 nodes. 1, 2, 3, 4. So we have 4 nodes here. Now if I ask you how many nodes are here, so we say the formula is n squared minus n divided by 2. We get a possible number of nodes, okay, of the ties, connections. So that will equal to, okay, that will equal to, let me just remove this one, okay. Okay, so that would equal to n squared, that is 4 squared, because there are 4 nodes, right? 1, 2, 3, I removed the other, but there are 4 nodes. So 4 squared is 16. Minus 4 divided by 2. So in that case, you get 12 divided by 2 equals to 6. So there are 6 possible ties. So let's do that manually again. Okay. Node 1, 2, 3, 4. Each one is connected with everybody else. Okay, and this is connected with this. Number of nodes, 1, 2, 3, 4, 5, 6. So they are total 6. Okay, great. Okay, so however, for the directed network, it is like it's the same formula, but you don't divide by 2. In the case of directed network, is like you have a both subordinate, you have chair of the board and members. So there is sort of like influence. For example, if you are asking an advice from someone, so then there is sort of influence. You are asking for an advice, so the person more likely might influence on the way you will act, or giving order, etc. Okay, so let's take example of that. Now let's say let's go back the same 4 nodes. You have 4 nodes, 1, 2, 3, 4 nodes. Okay. Now we ask you how many possible ties there are. Now the formula the same is, but you don't divide by 2. N squared minus n. That's it. Okay, how many n do we have here? 1, 2, 3, 4. 4 squared is 16. Divide by n, which is 4. You get 12. So let's do if there are 12 or not. So let me just use a different color. So you have, it is directed. So this one is influencing this person. Or, so basically when we talk about Twitter, let's say retweet network. Who is retweeting from whom? So if this person A, oh, let me write this. Okay, so let's say this A, this is B, this is C, this is D. So if this person retweets this person's message, it means that this person was influenced by this guy. And if this person also retweets from this person, so let's B, this is the guy B, has posted a very popular tweet and everybody is retweeting from him. It means that people like, it means like people have been influenced by his tweet and they started retweeting his message. I want you to just understand from Twitter perspective, because you'll be analyzing Twitter data in this in your project. Okay, so if this person retweets from this, it means that this gets popularity. Do you remember that now we call this, this person B has high number of in degree centrality, if you remember, in degree centrality, in degree. So in degree, but this person has one out degree. You see, in degree is one of the main measures of centrality measures. Okay, and if this person also retweets from this guy, now this guy becomes even more popular. And because of that, when we design like a network in social media, like in Twitter, you would find like this node, we can change the size of the node to be big to reflect the in degree centrality. We'll talk about later on betweenness. We already talked about betweenness centrality, closeness centrality, in degree, out degree. Okay, so but now let's go back to our own formula. Now this person also, okay, now let's see, this person might also retweet this guy message, or is connected to this, and this might also do this, and this might retweet from this guy. You'll be like, oh, they are only 1, 2, 3, 4, 6. No, 6 only in case of undirected network. So let's change the other. Let me change the color. So if this A retweets this person's message, maybe this also retweets this guy message. You see what I mean? Now there is this mutual relationship, mutual connection, reciprocal relationship. So maybe this one also retweets this guy's message. You can look at it from a different perspective, not necessarily from Twitter. I'm talking about Twitter because that is your project. Maybe A is seeking an advice from this, and this is seeking an advice from this person. Now the same thing with this B might also seeking an advice from this, or is retweeting this guy's message. This person might also seeking an advice from this, or retweeting this person's message. The same thing with this, here from here. Equally is true from B to D, so this also can go this way. So two ways connection, and this way can go. No, this one can also go this way. You see. Now let's count the number of possible ties. You have 1, 2 here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is our answer, 12. So there are total 12 number of possible ties, directed connections. Now, if you have like a network of Twitter network of like 1,000 tweets, if they ask you, okay, how many possible directed connections there are, with a single formula, you'll be able to do that. Just keep this back in your mind, how the Twitter functions before you start analyzing Twitter data. Okay, so let me just go back to the slide. Since we already talked, we have already explained in week 7 or 6. I won't cover all the slide. This is just to remind you of these concepts, to refresh you from a 1 month, break. Okay, so I need to focus on the things that are very important. Yeah, triadic network is like if A is connected to B, B is connected to C, then A is also connected to C. This, I think we discussed about this when we talked about transitivity, in I think PowerPoint number 3. Now, there are two main ways of analyzing networks, graph theory and matrices. You need to just to have a clear picture. Mainly, you'll be using a graph theory in this class because this is not like a pure math class. It's more intended for you guys, like business students, where you can use social network analysis in analyzing Twitter data and social or relational data. We discussed about this. A graph, like a graph where you have a node, ties, or edges. Nodes are also called vertices. It depends on different software. They give you a different label. The connection, the lines, they are also called edges, arcs. Okay. You might have like different clusters, components, sometimes they are called. subgraphs. If you analyze COVID-19, you will find some people are clustered in one group and other people are clustered in another group. Probably this group A are only retweeting and replying to each other about a particular topic, and the other group, they are talking about something else. We discussed about a walk. If you remember, we spent several time, maybe 1-2 lectures discussing about these concepts. We discussed about a trail and what is a path, and for example, a path is like the way how you can reach a person. We can say from Mira to Saada to so this kind of a walk, Saada to Salma to Ali to Ahmed over here. So this is kind of like a path, you see, just to remind you. But now the thing is that you need to be there might be multiple paths. If I ask you from Mira to Ahmed how many possible paths are there, you have this, you can see now that is one possible path. Yes. What if from from Mira to Ali, how many possible paths? Okay, from here to here, that is one path. And another one from Mira to Saada, Saada to Salma, Salma to Ali. That is another possible path. So there are two paths. Now the shortest path is called geodesic. We discussed about that. Okay, here are the definition. Please go and check those out. Geodesic is the shortest path. Okay. Let me just go back again. Let's see to cover most important things. Okay, here we are. Just to remind you of the matrix. Okay, so I don't want to make this very long. Now, usually whenever you do you download Twitter data, most of the programs, they will convert whatever you have into matrices. I mean, everything is in matrices. Even if you are using Microsoft Excel, like you have rows and columns, that is like a matrix. You use any software, even if you are using SPSS, you have rows and columns. However, the software would eventually convert everything into a matrix, and then the calculation will be performed using these matrices. Okay, so let's take an example here. If the person P1, if you can ask people, stranger, familiar, friend, a very close friend, if there is a person who is a very close friend to you, you will have 3. For example, P2 and P1, they are very close friend, number 3. Okay, now what does that mean? Always the what do you call? Let me just write here. The rows here, these are the rows, are initiators, are the senders. Those who are in columns here, these are all you can consider as the receivers, of the relation. Send this one sends this a receiver. So this is choosing this. P2 perceive that P1 is a close friend. Let's take another example here. Okay. I cannot move 1 minute. Okay, so basically, let's take the following example. You can see here, for example, you can see, let's say take Salma. The row is connected with Ali. If there is 1, it means there is connection. 0, not connection. Now we say that rows here are the initiators, the senders, and these guys, the columns, are the receivers of a connection. So this is connected to this. There is a line from Salma to Ali. This is a matrix. Let's check the sociogram, Salma and Ali. Where is it? Salma and Ali. See this here? You can notice this is Salma over here and this is Ali. So Salma is seeking an advice from Ali over here, and because of that, we see the value in the matrix is 1. Salma is not connected to Ahmed. Salma, so it will be 0. Let's go and check it out. Salma and Ahmed. Salma and Ahmed. Can you see? Here is Ahmed. Down 0, Salma. So just have a big understanding of the matrix. We discussed about density, centrality measures, and so for now I will just keep it 20 minutes because we have already covered this class. Just whenever you do your research, remind directed network, undirected network. Remember the number of nodes you have, the density of the network you have, the centrality measures that you will be using. You might want to go back to lecture number 3 or slides number 3, and that's it for now. Stay at home and stay safe. Thank you very much.